Question 9. Find the set of values of k for which this equation has two distinct real roots. It's looking like a quadratic equation, and we know from experience that quadratic equations have to be equal to 0 before we can do anything useful with them. So the first thing to do with this is get everything over to one side. This is x squared plus 2x plus 11 equals 2kx minus k. So I want to bring everything over to the left-hand side. X squared plus 2x minus 2kx plus 11 plus k equals 0. I need to collect terms together. So we've got x squared plus 2 minus 2k lots of x plus 11 plus k. So there, as soon as we talk about discriminants, we're thinking ax squared plus bx plus c is 0, and if it's two distinct real roots, that means b squared minus 4ac has to be greater than 0. If it was equal to 0, they would be real roots, but they'd be the same. But two distinct real roots means greater than 0. So that's what we're doing. We're taking those values. So a is 1, b is 2 minus 2k, c is 11 plus k. Let's work out the discriminant. That is 2 minus 2k squared minus 4 times 1 times c should be greater than 0. What we're going to do, carefully deal with the brackets that we've got here. I think we've got 4 minus 4k minus another 4k, so minus 8k plus 4k squared minus 44 minus 4k is greater than 0. So we've ended up within the discriminant with 4k squared minus 8 minus 4, so minus 12k, and 4 take away 44 is minus 40, has got to be bigger than 0. Which there's clearly the common factor of 4 in that. K squared minus 3 minus 10 is bigger than 0. How are we getting on with that? We've got something that we can work with. We can factorise that. 10 is 5 2s, and that would work. So that is k minus 5 k plus 2, is that right? Giving us critical values of k equals 5 and k equals minus 2. It's an inequality. Remember, what we're sketching now is the value of the discriminant. We've got it crossing at minus 2 and plus 5. So there it is. We wanted to know when was it less than, when was it greater than 0? It's greater than 0 for the x values that are yellow there. That is minus 2, that's plus 5. So k less than minus 2, k bigger than 5. Those values would give us the region that we want. They would make the quadratic we began with have two distinct real roots. There we are. The crucial thing, the thing where it went wrong for some of you was just that algebra of rearranging at the moment. It's amazing how many people took 2kx minus k to the other side of the equation and made it minus 2kx minus k. Kind of somehow carried the k with it instead of changing the sign of the k when it went over, and then didn't manage to separate it into a, b and c correctly at that point. But there was nothing difficult about that as long as you were careful with it. And there, which one was it? There it was. There's even one there where you have to take x out as a factor in order to deal with it. So very, very similar to what what we've just done in that. There we go. And that's the discriminant. Tom's not stopping it.